let's hand over next to Dmitry. And if Jonathan can set up his screen sharing, that would be fantastic.
All right. Yeah, I will keep this presentation a little bit less formal compared to previous one because, yeah, I want to make it interactive. And in my talk, I will focus on like data scientist perspective on the geospatial analytics and especially AI and computer vision problems. So yeah, I'm Dmitry. I'm founder of Rexy, where we build.
Lost audio.
Yeah, I think we've lost your audio, Dmitry. Can you hear us still? I can see that your microphone is still on.
We can still see your screen, but we can't hear you.
Can you hear me now?
Oh, yes, we got you now.
Yeah, I think that's related to the ability of this software to automatically adjust the call volume. So it's kind of reducing the input. Where can I fix it?
You sound fine now, so I think you should just
continue. Yeah, okay. Yeah, so at Rexy, we built a platform for no-code or low-code AI on satellite and aerial images. Namely, it allows domain experts and business users to annotate a couple of objects on satellite or aerial images and then write on the browser to train AI models and then run this on larger scale. And the cloud optimized GeoTIFF is really the core technology which enables all our workflows. Now let's try to get a step back and take a look on the challenges which typical data scientists face first when work on the computer vision problems on geospatial data on satellite images. First of all, the images are really huge, and typically you cannot process the whole image in one pass, so people make chunks of images and then process each small grid and then combine the results together in order to, for example, detect objects or detect buildings. But in reality, things are a little bit more complicated because when you divide image into chunks, there could be some border effects where your AI model won't be able to detect the objects on the border. So typically people do chunks with overlap, and this is where things are getting complicated because you need to resolve a lot of collisions. And you can imagine that working with the just GeoTIFF files is a big mess because you need to manage all these small chunks somewhere on the disk and clean up and so on and so forth. And later on, I will show how we adapted cloud optimized GeoTIFF to run all this analysis on the fly without need to manage all these smaller files on disk. The next part is the geospatial specific of the data, and namely projections, which can surprise the people outside of geospatial. And the very same image may look very different for human and for algorithm, for computer vision model, and that can affect performance. So we need to account this as well. And thanks to, again, to cloud optimized GeoTIFF and the GDAL, we can do that on the fly. And I will demonstrate later how smoothly it can be. And the last part, which we will touch here in the presentation, is the resolution or ground sample distance. For example, if you have your models detecting cars work on 50 centimeter per pixel satellite data, it might not work on the high resolution drone images with the 5 centimeters per pixel, because just your objects which your model expects to see are much smaller. And now I wanted to just demonstrate the workflow, which is powered by Cloud Optimized GeoTIFF, which solve all these issues I mentioned before. Just a second. Yeah, basically, in the platform we are built, we make it really simple to run analytics on the Cloud Optimized GeoTIFF. So if you store your images somewhere in the cloud, you can just provide a URL to this image. And thanks to the way how Cloud Optimized GeoTIFFs are organized, they can be efficiently streamed and no need to copy data. So you can run your analytics like in real time. So I provided a URL to GeoTIFF, then I can select the model. For example, I want to detect cars, and then all the cars will be detected in like seconds. So you don't need to copy anything anywhere. And I think that's the whole point of having the cloud optimized format and the tools around cloud optimized GeoTIFF to make it really smoothly. Yeah, so it took about 20 seconds to detect all the objects. And now I wanted to share the last part. So sometimes it's okay to run the analysis offline, but there are events, for example, disasters, when every minute counts. And Maxar, for example, have a program related to natural disasters. So after flooding or some huge event happens, they share the high-resolution data free of charge, which you can directly use. And it is already in the analysis-ready format, in a COG format. And we made a proof of concept where you can just copy a link to the COG file shared on the with the Maxar. Actually, they are stored on AWS S3. And then you can detect damages right from your browser without need to do any engineering. So what we do, we just copy URLs from Maxar Open Data to what we built to our platform, and then in like 3 minutes you can get all damages detected right from your browser, and disaster response team can make a quicker actions on the damage. Yeah, that's pretty it. I think I'm running out of time, so it will take about 3 minutes to finish in this huge area of like about 2,000 square kilometers. But yeah, just summarizing, Cloud Optimized GeoTIFF is a really enabler of the real-time analytics. It's not just a format for visualizing your data. It is much more, and in future we will see more and more applications which leverage Cloud Optimized format for real-time analytics.
Wonderful. Well, thank you, Dmitry. That's a really cool application. Do we have any questions rolling around for Dmitry? Thank you very much again. There's a couple of notes on here. Custom models. So, Dmitry, can someone bring their own model along to your platform?
Yeah, there are two options. Either you can train. Yeah, there are two options. So either you can train your custom model to detect custom objects right on the platform and then in one click deploy. Or if you have your own models, you can use an SDK and you can essentially upload like ONNX file to the platform, and the platform will take care of like distributing the workload and teaching results back. Yeah, so we do support.
Great. Oh, let's leave that one there. Thank you very much again, and